Java code will take place and what is exactly the Java compiler and what is exactly the JVM. Can you please tell me what is the main role of a JVM, Elena?
It's to take the Java code and put it into a byte code.
Which is the main responsibility of the JVM?
Isn't it to take the Java code and put it into byte code and then machine code?
Yes. The main responsibility of the JVM is converting the bytecode instructions into the machine language.
Okay.
Okay.
Converting the bytecode instructions into the
Machine
language.
Mm-hmm.
Now, JVM, okay? The responsibilities, okay? The main responsibility of the JVM is to convert the
Bytecode.
bytecode instructions. Now, who will generate the bytecode for my Java code, in my Java code?
Is it when you change it into dot class?
Right. Who will generate the dot class file? The Java compiler.
Okay.
Once I compiled my Java code, then a dot class file will be generated.
Mm-hmm.
This dot class file contains the bytecode instructions. Generally, the processor will not understand what exactly the bytecode instructions are. It means maybe some processors will understand the bytecode instructions and some processors will not understand the bytecode instructions. So we cannot give any assurance on that processors, all the processors will understand all the bytecode instructions. But Java says that it is completely a platform independent programming language. The platform independent means wherever you want to run the application, yes, it will run. So how can we say that this one? So that's the reason why the JVM will make our Java code to be run in any environment or in any platform, or it makes our Java code to work independently on your machines. That is what exactly the main responsibility of the JVM. So the main responsibility of the JVM is to convert the bytecode instructions into machine language. Converts the bytecode instructions into machine language. Now, who will understand the machine language?
The
Yes.
processor, probably?
Right. Who will understand the machine language means you or me or Milan cannot understand the machine language.
Mm-hmm.
Machine language will be understandable only by the processor. Okay? So, the machine language according to the processor of your machine. See here, according to the processor of your machine means the JVM will not generate the bytecode instructions according to its own. It will work according to your processor.
Mm-hmm.
If JVM is available in your machine, then it will work according to your processor. If JVM is available in Elena's machine, then it will work according to her processor.
Mm-hmm.
If JVM is available in my machine, then it will work according to my processor. Okay? That is what exactly it will do. This is the main responsibility of the JVM. Any questions up to now, please ask me. If you have any doubts, please ask me. Minal?
Yeah. No, I'm able to understand. As I'll understand, like I'll have, if I have queries, I'll definitely ask.
Right. Now, Aida, is it clear for you, right?
Yeah.
Right, fine. Now in this session, we are going to see the architecture of the JVM.
Mm-hmm.
Generally, guys, the JVM architecture we no need to discuss here. Okay?
Mm-hmm.
But why we are discussing the JVM architecture is, maybe in future, if you want to plan to move on to some other technologies like the WebLogic or the WebSphere or something, there the JVM plays a very, very important role. For that purpose, there the JVM only plays a crucial role in maintaining of the applications. So if you discuss now itself, so that it will be easy for you to understand what exactly the responsibilities and the roles of the JVM. And one more thing is that if you understand the JVM architecture, then you will get a clear clarity on what exactly the Java is and how exactly we are learning the Java in our training part and everything. Okay? Now, please listen to me now. The very first component of the JVM is class loader subsystem. Okay?
Mm-hmm.
The first component of the JVM is class loader subsystem. Okay? Class loader subsystem. Now, we will see what is a class loader subsystem. The class loader subsystem is the component of the JVM architecture. Okay? The main responsibility of this class loader subsystem is the main responsibility of the class loader subsystem is allocates the memory for the dot class file which is generated by the Java compiler. Now, who will allocate the memory? The class loader subsystem, which is a part of JVM, will allocate memory for the dot class file. Okay, next one. Once the dot class file loaded into memory, once the dot class file loaded into the memory, then this class loader subsystem will check. Now tell me guys, what exactly the dot class file consists of?
Compile file, right?
It's a compiled file, but what it contains?
Bytecodes, right?
Right. So,
Yeah.
once the dot class file loaded into the memory by the class loader subsystem, the class loader subsystem will check whether the bytecode instructions are proper or not.
Okay.
Okay.
Yeah.
It checks whether the bytecode instructions are proper or not. It means here two scenarios. Okay. One is what the class loader subsystem will perform or will do when the bytecode instructions are proper, and what exactly the class loader subsystem will do when the bytecode instructions are not proper. Now, if the bytecode instructions are not proper, then what the class loader subsystem will do? Then the class loader subsystem will stop the execution of the code. Okay. If the bytecode instructions are proper, then the class loader subsystem Will anyone of you tell me what the role of the
It will execute?
Yeah, it will probably execute, right?
You are almost correct, but before going to execute the Java code, it will do a small base steps here. Now, the class loader subsystem will divide the memory into 5 different areas. We'll divide the memory into 5
different areas.
Yes. This is the role of the class loader subsystem. Okay. This is the main role of the class loader subsystem. Now, overall, from this explanation, we have to come to an idea that memory allocations will also be taken care by the JVM. Whatever the memory issues you require, whatever the memory allotments you want for your Java code, all those things will be taken care by the JVM and not by you. Automatically, it will take care of that one. Okay? That is the reason why it is dividing the memory into 5 different areas and everything is proper. Okay? Now let's have a look at the 5 different areas.
Okay.
Elena, is it clear for you now?
Yeah.
Right. Now. Five different areas. Okay, 5 different areas. The first one is the method area. What is that one?
Method area.
Second one is the heap area. The third one is Java stacks. The fourth one is PC registers. Okay. Fourth one is PC registers. And the fifth one is native stacks. Fifth one is native stacks. These are all the 5 different memory areas that will be divided by the JVM. Specifically, the component is the class loader subsystem. Okay? Now, first of all, we will see each and every memory area and then we will go through it. Okay? Yes.
Yeah.
Method area. Can anyone of you tell me what is exactly the method area?
The methods we write. Sorry, yeah, you can go ahead. Yeah.
Oh no, I was just gonna say I don't know.
Okay. Is it the methods what we write for Java? Does it allocate while the bytecode for associate for this?
Now we will see what is the method area. Okay? Now,
yeah.
This is the block of memory area. Okay, this is a block of memory area which allocates memory for the code of the variables and code of the methods. Okay, it means it will allocate the memory for the variables and methods, but we don't know what is a variable and what is a method. Now see, in Java, whenever we want to store some data, okay, whenever you want to pass some data, then we need to use a variable. Then we need to use a variable. Alina, please observe this carefully, okay?
Sure.
Variable. A variable means which holds some data, which holds some value, which holds some information. Okay? If I want to store some data means then definitely in Java I have to use the variable. Okay? The variable will be like this. Suppose you are going to write a program like addition of two numbers. Okay? Addition of two numbers. So it means you need two input values, right?
Right.
Yeah.
No. I equal to 10. J equal to 5. Now see. This I and J, these two are variables. And 10 and 5 are the values of the variables. So every time if you want to define any data based on your code, based on your requirement, you will define some variable. Okay? Now, if you want to store some student information, okay? Now see, student information means definitely I should require the name of the student, right?
Right.
I require the address of the student. Gender of the student. And like this, if I want to store some data or if I want to handle some values, then I need the variable. Now, yesterday itself I told you that object-oriented programming language always deals with a class and an object, right? The class always contains the code of the variable. The class always contains the code of the methods. So all this information will be available under a Java program. That Java program will always be started with like this: class app. App is nothing but the name of the Java file. You guys understand the variables?
Yes.
Yes.
The basic structure of the variables. So
Yeah.
now see here, the code of the variable. So we are very clear on the code of the variable. The code will be always be like this. Okay?
Right.
It should be a name. It should be a number. It should be a anything. Okay? It should be anything. If you want to pass some information, yes, you can pass it very easily. Okay? Now,
Yeah.
let's see what is the code of a method. Code of a method. I will write it here. Code of the method. Can any one of you tell me what is a method?
Is a method a piece of code that does something?
Right.
So like,
Method always contains some logic.
okay, so like if
Method always contains some logic. If you want to write some logic, yes, you can define your method. There are two types of methods. One is the user-defined method and other is the predefined method.
Okay.
We will discuss about the method later on, okay? But
Sure.
just try to understand the general structure of a method, how the method will look like. Now, the method will always contain some logic. Okay, suppose if you want, actually, I just want to write a method which will display some addition of two numbers. Okay, previously we defined the variables and now we are going to execute the logic of that particular code. Now, how to write a method? The method signature, okay, the structure of a method will be always contains method name with the method body. Okay, method name means name of the method. Okay, method body means logic. Okay, method body means logic. Or it contains a group of statements. Contains group of statements. Okay, this is what exactly the method signature. How a method will look like? The method will always contains a method name with a method body. What is a method name means? Whatever the name you will define for a method, that is what exactly the name of the method. Whatever the logic you will write inside the method, you will define inside the method, that will be called as a method body or the logic, or I can call it as also as a group of statements. Now, let's see what is the method signature. Okay, I mean method signature means the structure of a method. The structure of a method. I will show you here itself. Now, Elena has to tell me what is exactly the method name and what is exactly the method body here. Okay? Observe this carefully. Now, Elena, please tell me what is the method name here and what is the method body here.
The name would be add, and the system.out.println would be your body.
Right.
Right. I can define any number of group of statements.
So anything between your two parentheses would be your body?
Anything that will be treated as a logic of that particular method. That's it.
Okay.
Okay?
So then do like variable names count as being in your body?
Later on we will see, we will combine the variables and methods and we will write a complete Java application and everything. Just try to understand how the variable will look like, how the method will look like, because we are going to discuss about the architecture of the JVM, right? A overall introduction of the Java will coming into the picture for you. Okay? Now,
Okay.
it's clear for you now?
Yeah.
Yeah.
Right. Minal, do you have any questions?
No, not yet.
So I'm going to remove all these things. Now, what is the next memory area?
Heap area.
Right, heap area. Heap area is a block of memory area okay, heap area is a block of memory area which holds or which allocates memory for the object. If you are having any objects in your Java code, all those objects will be maintained in a separate block of memory area called as a heap area. Okay. But we don't know what is an object, right? Don't know what is an object. And how can we understand this statement? So again, coming back to the Java code, and I will show you why we need an object. Generally, guys, object means physical representation of a class, or someone will call it as an instance of a class. Generally, it will be called as an instance of a class. Okay? But the main meaning of the instance here is that one? The main meaning of the instance here is the physical representation of a class. How to make a physical representation of a class? Why we need to make an object? Why we need to create an object? Now, listen to me carefully. This is very, very important. Why we need to create an object means to access the method or to execute the method okay, to access the method or to execute the method, we require we need an object. Okay. To access the method or to execute the method, we need an object. So why we will create an object? Why? Because to access the method. Whatever the methods you are having in your Java code, all those methods will be accessed by the object only. Okay? All
Yeah.
those methods will be accessed by the object only. You can create any number of objects. For suppose, if you have 1 to 5 methods, then you can create one or more objects to access the method. Even if you create one object, that is enough to execute that particular method. Okay?
Yeah.
Elena?
Yeah.
Following me, or do you have any questions, please?
Yeah. I follow you.
Please don't feel shy or something here, okay? We are here to learn Java. Please be free and ask me questions if you have any doubts, okay? Just
Sure.
you are here to learn Java. Don't feel shy or something, okay?
Yeah.
So we need to create an object. Why? Because to access the method, we need to create an object. You can write any number of methods in my Java code, but one object is enough to execute all those methods. Okay?
Yeah.
For that purpose, we will use a memory area for maintaining the object that is called as a heap memory area. Okay? Heap memory area. Now, later on, we will discuss more on the objects and everything. Okay? Just object means a physical representation of a class. Object means a physical representation of a class. Yes. Now, the next block, what is the next block of memory area?
Yeah, Java stack.
Java stack. Now, Java stack. Can any one of you tell me what is exactly the role of the Java stack?
No, I don't know.
No, I don't know as well.
Java stack is a block of memory area is a block of memory area which allocates the memory for the result of the method.
Okay.
Anyone of you tell me the meaning of this statement?
So when your code runs,
we know what is a method, right? We know what is a method, and we know how the method will look like. But here, method will be stored inside a, basically where the method will be stored, in which block of memory area?
Java stack.
Method will be stored in the method area, right?
Right. Yeah, memory method. Right.
Method area. First one is the method area. Now, this Java stack is saying that, hey, I am here to allocate memory for the result of the method. Oh my God! Here it means method, and method contains some result.
So the method and the method's result will be stored in two different areas.
Now, method will be stored in the method area. Method result will be stored inside a separate block of memory called as a Java stack.
Okay.
Now, if you see the meaning of this one, public void add system.out.println of suppose I am having I plus j. Okay, I have I and j values. Now I plus j will be
Result.
right. The result of this is will be
15.
stored inside the Java stack.
Java
Suppose if I is equal to 1 and j is equal to 2. Now, Elena, please tell me what is the value of I plus j?
3.
Right, very good, wonderful. Now, here the 3 will be the result, right? I plus j is the logic, and the output of this one will be the result. That result will be stored inside a separate block of memory area called as a Java
Stack.
Called as a Java stack. Now, what is the next block of memory area?
PC register.
Right, PC registers. PC registers. PC registers means the full form of PC here is program counter. PC means program counter. The main responsibility of the PC register is the responsibility of the PC register is allocating a thread to each and every method. What the PC register will do? It will allocate a thread to each and every method that we have in our Java code. Okay.
Okay.
Now, what exactly that thread is? Anyone of you can tell me what is a thread?
Oh.
Elena.
No, I don't know.
Thread means a process. Okay?
Okay.
Thread means a process. Okay?
Yeah.
So, if you want to execute a method, internally the PC register will allocate a thread to that particular method. If you have two methods, then two threads will be allocated to these two methods. It means one thread for the first one and second thread for the second one. Again, if you have n number of threads, then again each and every method will be having an thread which is allocated by the PC register. Like this, it will work. Okay, like that it will work. And then what is the next block of memory area we have?
Native stack.
Native stack, right?
Yeah.
Native stack. Native stack is a separate block of memory area. Native stack is also a separate block of memory area. It will be useful for you for maintaining the native methods. What is that one? For maintaining the native methods. Yes, for maintaining the native methods. What is a native method? Native stacks will give support for the native libraries. Okay? The native stacks will give support for the native libraries. Native libraries means these are the libraries that will be maintained or that will be used in the C language. Okay, these are the libraries that will be used in the C language. Then why they included this one in Java? Why? Because maybe in future, if anyone tries to use the native libraries in Java, yes, the JVM will give support for such functionalities also. That is the reason why they provided this particular block of memory here. Okay? Yeah. Only for supporting the native library. Up to now, we discussed all about the memory allocations, for the Java code and everything, right? But we didn't talk anything about the conversation of the bytecode instructions into the machine language. Right? We didn't talk about the conversation of the machine language. Now we are going to talk about that one now. execution engine, which is a part of JVM. This part of JVM converts the bytecode instructions into the machine language. Basically, execution engine contains two components. One is the interpreter, and the next one is the JIT compiler. Okay?
Yeah.
Interpreter means is a component which converts the bytecode into machine language, which converts the bytecode into
Machine
language according to the processor of your machine. According to the processor of the
machine.
The interpreter is available in your machine, then it will work according to your processor. If the interpreter is available in my machine, then it will work according to my processor. Like that it will work. Okay? Now. In addition to the interpreter, they provided another combination, that is JIT compiler. The full form of the JIT is just in time compiler. What is that one? Just in time compiler. The only responsibility of the just-in-time compiler is it will speed up the execution of your Java code. That's it. Okay. It will work as similar to that of the interpreter, but it is makes the execution very fastly. That is what exactly the combination of interpreter and the JIT compiler. These two things plays an important role in converting the bytecode instructions into the machine language. Okay? Understood?
Yeah.
Elena?
Yeah.
Do you have any questions on this one?
Nope.
Is everything clear, right?
Yes,
Yeah.
yes.
This is all about the Jvm architecture.
Okay.
This is how exactly the Jvm architecture splits the memory into different areas and allocates the memory for all the components that what we are doing in our Java code.
Mm-hmm.
You are not going to split the memory here. In C language, you are the responsible person to divide the memory into, to allocate the memory for the code for what you are going to use. Okay? But here, it's not like that. Here, it's not like that. You don't need to worry about that one. Everything will be taken care by the Jvm only.
Mm-hmm.
Okay? Everything will be taken care by the
JVM.
Yes. This is all about the responsibilities and the roles of the
JVM.
Okay. I think so that you understand what is a variable and how a method will look like and what exactly the importance of the object and everything.
Yeah.
Right? Okay, guys, we will meet
Okay.
on the next session, and we will
Okay.
discuss more